We are on page 109 of your workbooks. It should say 5.3. We're going to be solving systems of linear equations by what's called elimination today. Okay, and if you just think of the word elimination, if you eliminate something, you're wanting to get rid of it. So the whole point of this method, and you can write this up at the top of your page, is to get rid of one of the variables. So you want to get rid of either the x or the y. Okay, so what you're going to look for, we're still going to have our two equations because it's a system. Okay, so if you scroll down just a little bit, or if you, I guess, look down, I'll have to scroll. Right here where we have A, B, and C, right at the bottom of activity 2. Okay, what you are wanting to look for is either the x or the y. You want to see if they are direct opposites of each other. So meaning in one equation you may have a positive 5x, in the other equation you have a negative 5x. Okay, one will be positive, one will be negative, and they will both have the same coefficient, the same number in front of them. So, for instance, if you look at A right here, we first want to look and see if anything with the x or the y, if they are opposites. So I have a positive 2x in the first one and a positive 2x in the second one. They are not opposites. Even though they have the same number, they're both positive. Okay, for them to be opposites, one would need to be positive, one would need to be negative. So we look at the y's. Okay, here I have a plus y, and below it I have a minus y. Those are opposites. One's positive, one's negative, and they both have that invisible 1 in front of them. So that is what we are looking for. Okay, if you look at B, again, you have positive 3x, positive 3x, so the x's are not opposites. Move on to the y's. You have a minus y or a negative y in the first one and a positive y in the second one. Those are opposites. Negative y, positive y. In C, we have x and x, not opposites. They are the same. Both are positive. With the y's, I have a plus 2y and a minus 2y. Those are direct opposites. One's a positive 2, one's a negative 2. Okay, so over here to the side, what I want you to write first is simply all we're going to do to solve these is first you must find the opposites, okay, which that was what we were just doing. Decide if the equations do in fact have opposites. If they do, then all you're going to do is add the equations together. And then we solve. Okay? So we're just going to follow those 3 steps. So on part A, okay, I've already located our opposites. Those were the y's. So all I'm going to do is add these 2 equations together. Okay? 2x plus 2x is 4x. Plus y minus y cancels. That's what we are looking for. Equals 4 plus 0 is 0. Okay, so I have added them together. So notice what I have done is I have eliminated the y. Okay, hence the name, solving them by using elimination. So then we just solve this for x. Well, this says 4 times x. So to get rid of it, I'm going to divide by 4. So x equals 1. Okay, and then to figure out y, again, we've been doing this for the past couple of days. All you do is take this 1 And you can plug it into either equation that you want. It doesn't matter. It's probably going to be easier, and I will always plug it into the one that would give me a positive y. So I'm going to take that one and I'm going to put it right where that x is. So 2x, well, instead of that x, I'm going to put a 1 because that's what x equaled, plus y equals 4. Well, 2 times 1 is 2, plus y equals 4. And to get that y by itself, I need to subtract 2 on each side. So y equals 2. So we have x, we have y. Your ordered pair for this, your solution to this system would be 1, 2. Remember, we always list it as an ordered pair. Okay? And we're just going to do some practice with these. The more practice you do, the easier they will get and the more comfortable you'll get with them. So let's move over here to part B. Again, we have our opposites, negative y, positive y. So all we need to do is add these two together. 3x plus 3x is 6x. Negative y plus y cancels, equals 4 plus 2 is 6. And to get that x by itself, we have to divide by 6. So x equals 1. Okay? And then I need to know what y is. So this time I'm going to plug the 1 into the second equation because if you notice it says plus y and I won't have to deal with the negative. So 3x, well that's 1, so 3 times 1, plus y equals 2. 3 times 1 is 3, plus y equals 2. And then I need to subtract 3 on each side. So y equals negative 1. And when I write my ordered pair, remember it's always x and then y. So we have 1, negative 1. And there's your answer. Okay, on part C, same thing. We already have our opposites, the positive 2y, negative 2y, so I'm just going to add these together. X plus x. Keep in mind, each of these have a 1 in front of them, so 1x plus 1x is 2x. 2y plus a negative 2y is 0, so it cancels. And 7 plus a negative 5 would give you 2. Have to divide by 2 to get that x by itself. So again, we get x equals 1. I promise you won't always get 1 for x. And then we just plug it in, and I'm going to plug it into the one that's positive. So we have x, well that was 1, plus 2y equals 7. Subtract 1 on each side. So 2y equals 6. And then divide by 2 on each side. So y equals 3. So my ordered pair is 1, 3. Okay, now we're going to jump over to page 112. Let's flip over there. And it's the practice page at the top. And we're just going to work through a select few of these, and then we'll come back and do the others later. So the first one I want to look at is number 1 right here. So we have x plus y equals 7, 3x minus y equals 1. So we're looking for anything that may be opposites. So x and 3x. Well, those aren't even close. First of all, they're both positive, and this x has a 3 with it. That one doesn't. So let's look at the y's. I have a plus y on the first one and a minus y on the second one. So those are opposites. That's what I'm looking for, so I can eliminate those. So we're going to add these two together. X, remember that has a 1 in front of it, plus 3x would give me 4x. Y plus a negative y cancels. And 7 plus 1 equals 8. And to get that x alone, we divide by 4. So x equals 2. Again, I'm going to plug it into the first equation since that has a positive y. I won't have to deal with that negative. But instead of the x, I'm going to put a 2 because that's what we just figured out x would be. So I have 2 plus y equals 7. And I'm going to subtract 2 on each side. So y equals 5. So your ordered pair for this one is going to be 2, 5. Okay, let's look at number 2. Again, first thing we want to check is if anything ends up being opposite from each other. So I have negative 2x and negative 2x. These are not opposites because they are both negative. Okay, and then I have a negative 5y and a positive y. These are not true opposites. Even though one is negative and one's positive, the fact that this y has a 5 with it and this one doesn't, they will not cancel each other out. Okay, look at number 3. We have 8x and 2x, not opposites. 8 and 2 are not opposites. Negative 9y, negative 3y, negative 9 and negative 3 are not opposites. So nothing will cancel there. Number 4, negative 5x and 9x, those are not opposites. And positive 3 and negative 4, those are not opposites. So we will get to these later. Okay, right now I just want to focus on the ones that are already set up to cancel each other out. Okay, so the last thing we're going to do on number 5 is we're going to set up the system of equations, and then we'll worry about solving it later. So it says a high school has a total of 850 students. There are 60 more female students than there are male students. And part A says write a system of linear equations that represents this situation. So keep in mind, for it to be a system, you have to have at least 2 equations. Okay? So we know that the school has a total of 850 students. That's our first piece of information there. And you guys know to get the total, you would just have to add the number of females and the number of males. So for my variables, I'm going to use an F for female and an M for male. So we would have to take the number of females plus the number of males, and that would have to equal the total number of students at that high school, 850. For our other equation, we're going to use this other piece of information. There are 60 more female students than there are male. So there are more girls than there are boys. So to get the female students, to get the number of those, we would have to take the number of male students and add 60. So here is our system. We have our 2 equations set up, and we will work on solving this at a later time.